Hi College Algebra, here is a video on your 3.1 to 3.3 review. So we're starting off with just solving systems of equations. Notice it does not specify what type of method you need to use. Sometimes one will lend more to elimination or substitution than the other. So on this first one, I noticed that x is pretty x and y are pretty easy to get by themselves. I was going to get x by itself by just adding the y to the other side. So I have x equals y plus 4. Anywhere that I see that x, I can put y plus 4. So in the other equation where I see x, I can put y plus 4. So in the other equation, I have 4y equals 2x minus 4. Instead of x, I'm going to put y plus 4. I'll distribute this, so I have 4y equals 2y plus 8 minus 4. 8 minus 4 is 4. Subtract 2y to get it to the other side. And I got y equals 2. That is only the y part of my ordered pair. I need to plug it back in to get my x part. You can plug it back into one of your originals or even this equation. So if my y is 2, I'd have x equals 2 plus 4, and I end up getting that x is 6. Okay, next one. I had a lot of people ask about this number. Why isn't it on the other side? It's just not written in standard form, but it's not causing you any problems. You're welcome to move it to the other side if you'd like to. I went ahead and found a way to eliminate. I saw that I have a positive y here and a negative y here. We're going to have to multiply both of them, so I might as well pick the one that already has a positive and negative. I'm going to multiply my top equation by 5 and my bottom equation by 4. When I do that, my top equation becomes 25x plus 20y plus 10 equals 0. Then my next equation would be 16x minus 20y minus, 92 equals 0. I can check in a calculator. Yep, I got 92. And then we're going to try to combine these. When we combine, the whole goal is that you get rid of a variable, which we have done here. 25 plus 16 is 41, so 41x minus 82 equals 0. If I move the 82 over, 41x equals positive 82. When I divide by 41, I get 2. From there, you plug that 2 into either of your original equations. So I am going to just choose the first one because it's there. So 5 times x would be 5 times 2 plus 4y plus 2 equals 0. That'd be 10. 10 and 2 make 12. Subtract the 12 over and I get y equals negative 3. That would be an ordered pair with an x and a y, 2 as your x, negative 3 as your y. Very good. Moving right along. For this next one, I need to try to eliminate something. And so I noticed that I have 2x. If I multiplied this one by negative 2, I'd be able to have this be negative 2x, and those would cancel. So that's what I'm going to strive to do here. So if I multiply this by negative 2, my first equation can stay the same, so that would be 2x minus 8y equals 4. then my next equation is going to be negative 2x plus 8y equals negative 4. When I combine these, 2x minus 2x gives me a cancellation, but so does negative 8y and positive 8y. So I have 0 equals 4 minus 4 is 0. This is true. And anytime you get something that's true, your answer is going to be infinitely many solutions. I know that this isn't one that they gave you, but what if you got something that was like 0 equals 8? That is false, and that would be no solution. And you could write it as the no solution symbol. That's not what this one is. I just wanted to show you what that might look like on a real life example. Okay, this next one has a lot happening here. We have 3 equations with 3 variables we have to find. All right, here we go. I'm going to try to eliminate z. I see a positive and a negative. I'm just going to try to eliminate z. We can eliminate y also. I can't decide. Let's just eliminate y. Okay, so I'm going to pick the first 2, and I'm going to eliminate y. So to do that, I'm going to have to multiply the first equation by 4. That'll give me 4x plus 4y plus 4z equals 12. The bottom equation will be 3x minus 3y minus 4z equals negative 1. I didn't change that at all. When I combined these, I got 7x plus y. Oh my goodness. I'm not eliminating y, I'm eliminating z. I think that's what I was wanting to do from the beginning anyway. Plus 0z, so that goes away, equals 11. Okay, so I have 7x plus y equals 11. I eliminated z, and I did that by multiplying by 4. Okay, that's like my secondary equation A. I want to do the same thing and also eliminate the same variable, which, let me be clear, we eliminated z. So I'm going to pick a different 2 equations. We did 1 and 2. Maybe I'll do 1 and 3. And I want to eliminate the same variable, so also eliminate z. The only other way I can eliminate z is if I multiply my top equation by, let's see, a negative 3. So that'd be negative 3x minus 3y minus 3z equals negative 9. Then I have 3x minus 3y. Oh my gosh. The third equation is x plus y plus 3z equals 11. The whole point of doing that was so that these z's eliminated, and they do. So this will give me negative 2x minus 2y equals 2. I had some people notice that you can divide all of this by 2 or even negative 2, and you can do that. Divide by negative 2, and I end up getting x plus y equals negative 1, and that is totally fine. So that is what I'm going to use as my equation B. From here, we want to use equation A and equation B as our secondary equations. These are like any of these others where you just have 2 variables and you're trying to solve. I noticed that this has a positive y and this has a positive y, so I could multiply my B equation by negative 1, and I would get negative x minus y equals positive 1. When I combine those, I get 6x equals 12, and when I divide, I get that x is 2. I said you're going to use these secondary equations as if it was one of these others, so we're going to solve. We have that x is 2. Let's plug that back into one of these secondary equations. I'm going to do this one just because it's right here, so I'm going to plug in 2. So we have 2 plus y equals negative 1. When I subtract that over, I get negative 3. Now I have that my x is 2, my y is negative 3, and we need to plug that back into one of the originals. I'm going to pick the first one. The first equation is x, so 2, plus y, so negative 3, plus z equals 3. These give me negative 1. When I add that negative 1 over, I end up with 4. Make sure when you write your final answer, it's in an ordered triple, so it'll be x, then y, then z. My x was 2, my y was negative 3, and my z was 4. Very good. All right, this word problem is very similar to what you'll see on your test. We've got at Chick-fil-A, we're talking about sandwiches, we're talking about fries. They're asking find the cost of each menu item. So x is going to be the cost of the chicken sandwich. Y is going to be the cost of fries. Okay. They say they've got 2 orders here. So the first order is 2 chicken sandwiches, so 2x, and 3 fries, 3y is $18.75. And then the other order is that 5 chicken sandwiches and 7 fries is going to be $45.50. That's a lot to spend. So I need to multiply each and do some sort of elimination. I'm going to multiply my top equation by 5 and my bottom equation by negative 2. When I do that, I get positive 10x plus 15y equals, let's see, 5 times 1875 is 93.75. And then when I multiply the bottom equation by negative 2, I have negative 10x minus 14y equals negative 91. When I eliminate that x, I end up with y equals 2.75. That is the cost of my fries. To figure out the cost of the chicken sandwich, plug that 2.75 in for the y in one of your originals. It doesn't matter which one. I'm going to do this one just because it's right here. So we have 5x plus 7 times 2.75 equals 45.5. Let's see. I'm going to subtract that 19 number over, and I get 26.25. Hopefully this is nice to us. When I divide by 5, I'm running out of space, but I get that x is 5.25. And so that would be the cost of the chicken sandwich. Very good. Okay. Moving on, the difference of 2 numbers and then the sum of their squares. So difference means subtraction. So I'd have x minus y equals 8. We're going to say x is the first number and y is the second number. And then we're going to have the sum of their squares. That's addition, but it's of their squares. So x squared plus y squared equals 194. This is going to be a lot of algebra. I'm going to get y by, or x or y by itself. I'm going to add the y over, so I would have x equals y plus 8. Anywhere that I see x, I can plug in y plus 8. I see x here, so I'm going to have y plus 8 squared plus y squared equals 194. Y plus 8 squared, you have to FOIL it. So that'd be y plus 8 times y plus 8, then plus y squared equals 194. Y plus 8 times y plus 8 is y squared plus 16y plus 64. The y squared and y squared together will give you 2y squared. And then moving over the 194, I would get minus 130. I can divide all of those by 2, and I'd get y squared plus 8y minus 65 equals 0. Sorry for the bell. About to go to lunch. This is factorable because 65 is 13 times 5. If the 13 is positive and the 5 is negative, those would add to give me 8. When I set each individually equal to 0, I would get negative 13 and positive 5. That means there's 2 answers for the y, negative 13 and positive 5. You can plug that back into one of your originals. I'm going to do this first one. So if I plug in the negative 13, I would get x is negative 13 plus 8, and I would get that x is negative 5. When I plug in the 5, I would get x is 5 plus 8, so x is 13. And so you have 2 ordered pairs, negative 5, negative 13, and 13, 5. Make sure you put it in the order as x comma y. Great. All right, our favorite, everyone's favorite. We have a framing company. I always skip ahead and look. It says how many of each size of frame should the company use. So the variables, x is going to be the number of the first type, which is an 8 by 10. And then y is going to be the number of the next type, which is an 11 by 16. The objective of any business is always the money. So the objective function is going to be with the money. It looks like an 8 by 10 is $25, so 25 times x, plus the profit on a 16 by, oh, not 11 by 16, it's 16 by 20 size. And a 16 by 20 size is $30. So 30y, that's going to be your profit. Some constraints that you need to consider is that you have to have a positive amount of frames. You can't make a negative amount of frames. Then there are going to be 2 scenarios. One of them has to do with the mat and how long it takes to make the mat. The other one is how long it takes to make the actual wooden frame. For a mat, they tell you that an 8 by 10 mat takes 1 hour, so 1x. Later, they tell you that for a 16 by 20, the mat takes 3 hours. That's 3y. When you add those together, they tell you the mat department only has enough staff for up to 9 hours of labor. So 9 is a max. So it needs to be less than or equal to. For the frame, it says an 8 by 10, you have 6 hours to frame and 9 hours for the frame of the 16 by 20, and that department has 36 hours of labor. When you go to graph, x-axis, it needs to be labeled as the number of 8 by 10s, and then the y-axis needs to be the number of 16 by 20. Before I graph, I need to know what these look like when I have y by itself, like y equals mx plus b. So I'm going to subtract x over. I'll have 3y is less than or equal to negative x plus 9. And when I divide by 3, I'll have negative 1/3 x plus 3. When I do my other one, if I subtract the 6x over, I would have 9y is less than or equal to negative 6x plus 36. When I divide by 9, negative 6 divided by 9 would be negative 2/3 x. 36 divided by 9 is 4. Both of these can be graphed on this as if the my original graph is just 1, 2, 3, all the way to 10. Okay, and then graphing this first one, I start at 3, and I'm going to go down 1 over 3, down 1 over 3, down 1 over 3 for my slope. It is less than, so I'm going to shade below. And then this one, I start at 4, and my slope is negative 2/3. So down 2/3, down 2/3. So where is it overlapping here? It would be this quadrilateral. And I have vertices at 0, 0, 0, 3, 3, 2, and 6, 0. We need to plug that into the objective function, which we wrote above. That's the money. So that's 25x plus 30y. So it'd be 25 times 0 plus 30 times 0. I'm sure you're not surprised if they don't make anything. They're not going to make any money. If we have 25 times 0 plus 30 times 3, they're going to make $90. If they have 25 times 3 plus 30 times 2, they'd make $135. And then 25 times 6 plus 30 times 0, 150. So what is going to be the biggest bang for their buck? Because they're trying to maximize profits. So which one is going to be the max? That is going to be the 150. So since their max is 150, the answer is going to be how many of each size they need. So you would say it's 6 of your x, so 6 8 by 10s and 0 16 by 20s. Those 16 by 20s just cost too much to make, and it's not worth it for them to make those. So you would say the company should produce a max, or should produce 6 8 by 10 frames and 0 16 by 20 frames to have a maximum profit of 150. Okay, very good. I'm going to pause the video real quick, and I'm going to come back to this after lunch. All right, so I just unpaused it. We're going to go ahead and continue. These are graphing systems of inequalities. So I'm going to do this one in green. I need to get y by itself. So if I subtract 2x, I'd have negative y is greater than or equal to negative 2x plus 4. When I divide by a negative, I have to change my inequality sign. Now I'm going to plot this. Negative 4, and I have a slope of 2, so up 2 over 1, up 2 over 1. It's a solid line. And I'm going to shade below because it's where y is less than. Next one. I need to get y by itself, so if I subtract x, I'll have 2y is less than or equal to negative x plus 4. When I divide by 2, that is positive, so I don't need to switch my sign. I'll start at 2. I have a slope of down 1 over 2. Because of the equals to, it's a solid line. And I will shade, it is less than or equal to, so I'll shade below. So our final answer would be this double shaded region. From here to here, both of those are solid lines in this section right here. Okay, next one. Y is less than 5 is crossing the y-axis at 5. which is here. It is dashed because it does not have the equals to, and it's less than, so it's down below. This next one, I need to get y by itself, so I'd move the 2x over. I start at -3, and I go down 2 over 1, down 2 over 1, or up and to the left. It's solid because it has the equals to, and because it's less than, we're going to shade below. X is greater than -6. -6 crossing the x-axis is a vertical line here. It's just greater than, so it doesn't have an equals to. And greater than is going to be this way. One more, y is greater than or equal to 0. Crossing the y-axis at 0 is here. It's solid because it has the equals to, and greater than or equal to 0 will be above. So I'm seeing a little trapezoid. Oops, that would be a dashed line. So dashed. This is dash, this is dash, this one's solid, this one's solid, and it is just a little trapezoid. That is where all of them are shaded. Okay, moving right along. When you have matrices that are equal to each other, the corresponding elements are set equal. So 8 is set equal, that top left is set equal to this top left. So 8 is equal to C plus 3. When I subtract 3, I get 5 for my C. A minus 5 is equal to 4. Add the 5 over, and I get 9. B plus 2 is equal to 4. Subtract the 2 over, and I get 2. Move the 6 over, and I get 9. Very good. Okay, next ones are just asking about the dimensions of the matrices. Remember, it's always rows, then columns. Rows are like the floor of a house. Columns are like the columns of a house. So this has 3 rows and 4 columns. This is a 3 by 4. This has 2 rows, 3 columns, so a 2 by 3. This is another 2 rows, 3 columns, so another 2 by 3. And this has 1 row, 3 columns, so 1 by 3. These are asking if we're able to do the operation. They're not asking for the operation, but they're asking if we can do it. Is it possible? And then if so, what are the dimensions of your new matrix? Not asking for the new matrix, just what are the dimensions? Dimensions are the rows by columns number. So B plus C. You can add matrices that have the exact same dimensions. So you can do that. You would say yes, and you would end up with another 2 by 3. C minus A. You can only subtract matrices if they have the same dimensions. They do not, so you would write not possible or no. B times A. B is a 2 by 3. A is a 3 by 4. You can multiply matrices if that middle number is the same, and it is in this case. You would end up with a 2 by 4. So you would say yes, and you end up with a 2 by 4. A times B. That would be a 3 by 4 times a 2 by 3. That middle number is not the same, so no, you cannot do it. C minus D. You can only subtract whenever you have the same dimensions, and we don't have these here, so that would be a no. A times D. A is a 3 by 4, and D is a 1 by 3. That middle number is not the same, so you cannot multiply those. C times D. That's a 2 by 3 and a 1 by 3. Same thing. That middle number is not the same, so you cannot multiply them. And then D times A is a 1 by 3, and then A is a 3 by 4. That middle number is the same, so yes, you can multiply them, and you would end up with a 1 by 4. All right, moving right along. On this back page, it says use the following matrices to perform the operation if possible. We can see that this is a 2 by 2, and this is also a 2 by 2. When they're wanting negative 4b, they're wanting us to do negative 4 times the b matrix, which is negative 6, 2, 4, and 0. This is basically just distributing. Multiply that negative 4 into every single element in this matrix. Negative 4 times negative 6 is positive 24. Negative 4 times 2 is negative 8. Negative 4 times 4 is negative 16. Negative 4 times 0 is 0. That is going to be your answer. For the next one, they want us to do negative 5 times the A matrix plus 3 times our B matrix. Let's just distribute the negative 5 in. That would give me 10, negative 20, negative 5, and negative 15. Let's just distribute the 3 in. That would be negative 18, 6, 12, and 0. Now we can add matrices. You can only add matrices if they have the same dimensions. These are both 2 by 2s, so we're good to go. When I add matrices, I add the corresponding elements. So 10 plus negative 18 is going to be negative 8. Negative 20 plus 6 is negative 14. Negative 5 plus 12 is 7. Negative 15 plus 0 is negative 15. And so that is my final answer for that one. Now we're going to practice multiplying matrices. Remember, when you're multiplying matrices, you have to check the dimensions. This first one, this is a 2 by 2, and this is a 2 by 1. It's always rows, then columns. There's 2 rows, 2 columns. There's 2 rows, 1 column. That middle number is the same, so yes, we can do it, and we are going to end up with a 2 by 1. So that means when I multiply these, I'm going to end up with 2 rows and 1 column. Okay, here I go. Row and column. Negative 1 times negative 4 is 4. 5 times 3 is 15. Add them together, you'll get 19. Now I need to do my next row with this column. 7 times negative 4 is negative 28. 1 times 3 is 3. Add them together, and you get negative 25. This is your final answer. Next one, this is a 3 by 2, and this is a 2 by 3. That middle number is the same. Yes, we can do it. We will end up with a 3 by 3. All right, here we go. I'm actually going to grab some erasable pens for when I'm trying to circle my matrices and everything. Let's just do this one. Okay, so here is rows, then columns. It's always rows and columns. So 2 times negative 2 is negative 4. Move over and down. So 1 times 1 is 1. You add those together and you get negative 3. That's the first row and the first column. Now let's do the first row and the next column. 2 times 4 is 8. 1 times 0 is 0. Add those together and you get 8. You've done the first row with the first and second column. Now let's do the first row with the third column. 2 times negative 1 is negative 2. 1 times 2 is 2. Add those together and you get 0. Notice that the ones with the first row, third column, I'm putting in the first row, third column location. All right, next ones second row with each column. Second row, first column. 0 times negative 2 is 0. Move over and down. Negative 2 times 1 is negative 2. Together, that gives me negative 2. We're going to multiply the second row by the second column. 0 times 4 is 0. Negative 2 times 0 is 0. Added together, I get 0. Next one, 0 times negative 1 is 0. Negative 2 times 2 is negative 4. And together I get negative 4. All right. 3 times negative 2 is negative 6. This is the third row, first column. Negative 3 times 1 is negative 3. Together, that is negative 9. Oops, still third row, second column though. 3 times 4 is 12. Negative 3 times 0 is 0. When you add those up, we get 12. 3 times negative 1 is negative 3. Negative 3 times 2 is negative 6. Together, that is negative 9. So this is your final answer. It is okay if you don't write this step. However, if you choose to not write this step and you have wonky numbers here, it will be very difficult for me to know where you went wrong, and you're likely to lose all your points. So I want to make sure that you guys really know what you're doing if you think you're going to start skipping steps. Next one, we have a 2 by 2. Because there's 2 rows, 2 columns, and then this is a 3 by 2 because there's 3 rows and 2 columns. That middle number does not match, so it is not possible, and you don't have to multiply them if it is not possible. Last one, we have a 3 by 3 and a 3 rows by 1 column. That middle number does match, so we can do it, and we're going to end up with a 3 by 1. All right, 3 by 1, 3 rows, just 1 column. Here we go. First row, first column. 3 times negative 4 is negative 12. 2 times 1 is 2. 0 times 9 is 0. Add those all up and you get negative 10. Make sure you're going over in the row, down in the column. We've done the first row with the first column. There's only 1 column. And now we're going to do the next row. Negative 2 times negative 4 is 8. 7 times 1 is 7. 4 times 9 is 36. When I add all of those up, I get 51. Now we've done the second row with the only column that there is. So we're going to have the third row with this column. So 2 times negative 4 is negative 8. Negative 1 times 1 is negative 1. Negative 3 times 9 is negative 27. Together, that gives me negative 36. This is going to be your final answer. That should be it for your review. If you have any questions at all, please let me know. And good luck on your test.